Welcome to Luca and Miguel. Enjoy the video.
You start by validating prerequisites. Confirm your GPU supports CUDA and update the NVIDIA driver. Matlab needs the parallel computing toolbox. Once done, launch Matlab and run GPU device to select and inspect the device. This tells you index, name, compute capability, and available memory so you can plan workloads. Next, set GPU device N to lock that GPU for the session. These first steps establish a reliable execution environment, so computations move from CPU to GPU without surprises. You now move computation. Cast large arrays to GPU array so Matlab executes built-in operations on the GPU automatically. For element-wise work, use array fun. For batched linear algebra, use page fun. And when you need custom performance, compile a CUDA kernel with Parallel. GPU, CUDA kernel. Make sure to pre-allocate GPU array memory to avoid repeated allocations. Also, once data is on the GPU, group operations to reduce host device transfers because those are the main performance bottleneck. With these steps, you get consistent speedups for heavy numeric work. You finish by gathering results back to the CPU with gather, only for final outputs. Avoid frequent gather calls. Then profile using GPU device profiler and Matlab profiler to locate kernels or transfers that dominate time. If you need persistence across runs, clear GPU memory with reset, GPU device, or clear variables. A frequent problem is out of memory. If that happens, reduce batch sizes, use single precision, or process data in tiles. If errors persist, restart Matlab and rerun GPU device to reinitialize the GPU state.
Thanks for watching and please subscribe. It's the best investment you'll ever make.